Hi guys, I'm gonna solve medium level question with high frequency. Okay. So many questions. Not high frequency, but higher acceptance rate. It is a medium level question, and then acceptance rate is 94%. Wow. And then high frequency. So let's say frequency over like 50%. This one, oh, I solved this one. Design an expression tree with value blah blah blah. Okay, let's start. Reset the timer. Question is very long. Design an expression tree with evaluation function. Expression tree. Amazon, Google, Amazon likes this. Oops. So sorry. Given a postfix token of an arithmetic expression, build and return the binary expression tree that represent binary expression postfix token. So like 3, 4 plus 2, 7. Explain this expression, evaluate to the above binary tree with blah blah blah. Postfix notation. The class node in this you should use is an interface you should provide binary search tree. The return tree will be tested using the evaluate function, which is supposed to evaluate the trace value. You should not remove a node class, however. You can modify it as you wish, and you can define other class. The binary expression tree is kind of binary tree used to be. Okay. The binary is the 0 or 2 value. Okay. Leaf. Leaf node. You guarantee that no subtree will yield a value that exceeds 10 to the power of 9 in absolute value. Could you design the expression tree such that it is more modular? For example, is your design able to support additional operators without making changes to your existing evaluate implementation? Is your design able to support additional operator without evaluate? Okay. So 4, 5, 2, 7 plus so we'll have stack 2, 7, 5, 4, 2, 7, 5, 4, and then plus minus this seems like Q, right? Here 3, 4, and then push this, and then plus 2, 7, and then minus 5, then this 4. Okay. Okay, evaluate. Node is the interface you should use to implement binary search tree. The return tree will be tested using the evaluate function. So I'm calling evaluate in here. Actually evaluate everything. Is that what you mean? Output 2. Oh, 7. Oh, okay. I see. So virtual. Oh, I don't know why is virtual. Virtual. Yeah. This is pure virtual. So tree build a tree. This is the interface for the express tree node. You should not remove it, and you can define some class to implement it. Okay. Node impl. Virtual node. So what evaluate is actually you may want to open node and num node. The what open node, and in here what we can do is plus not plus addition add so should I do this? Add sub for the test. This is not a good way. Mul and then div so what add does is that left evaluate plus right this one, right? And then this is this and then this is multiplication, and this is division, right? And then and then in case of num, first num, it should have a val. So is it int? Its length is odd, it's constant number, and character number is integer expressed no more than this. The absolute value of the result and intermediate value will not exceed. It is guaranteed that no expression will include divide. Okay. Seems like it's int, right? Int. Because integer representation, blah blah blah. So seems like it's int. So int val num node, and then this, and then actually why do I really need this? I don't know, but I definitely need this val. So actually should something this is private. Okay, so these are done. This does not need this. Then this does not need this. Oops. Does not need this. Add and OP node. We don't need this. And then node evaluate left, right. Okay. So build a tree. So what it does is that it has stack of node node pointer. Okay. st. Okay. So for token auto token inside postfix. So we might have some function. Bool is op, character ch, and then turn ch so plus - and then division. Okay, So let's okay, if is OP, then we do something, right? Else push token and then toString s2i, not s2i, node. So what should we push into the stack? So in case of this one, we'll push 4, this one, and then the result of this one needs to be pushed, right? So this doesn't need to be node. This needs to be int, and then we need to build a tree. Yeah, we need to build a tree. So so if we found the plus, what we need to do is that build 2,7 and then push that into here. So this needs to be node and then what I don't like is that we have to return the node. So I guess the node will be, freed by the caller, right? So we don't need to do some unique pointer stuff. Okay, so this is not this. What we need is new num node and then a2i token. Okay, and if this we need to pop, right? Node. So which one should be first? Second. Pop, and then top, and then first, and then what I can do is that we may need some kind of factory, but let's do that later. So switch token case plus sub in case of this we're gonna push stack push and then new add with first and second, right? And then break, and we don't have this constructor, and then so OP node, public node, and we need this, right? OP node cannot be instantiated by any others, so we can make node left, other left, right, like this. So left L, right R, something like this. Okay, and then probably OP node. P node. This is for OP node. OP node, and then we need a constructor. So this is add, and then OP node LR, right? And sub mul div, right? And so this is some kind of factory, and then default throw error, no, not supported OP, and then this is div, this is mul, and this is sub. Okay, something like this. Okay. So after doing this, so here we pop this and add this tree. Then we pop this and add this tree, and then we pop this and add this tree. So we have only one node, return top. So here actually we may need some assert whether there's only one element in the stack. So yeah, so let's check whether this works. So let's say that test case. Let's try to write some test case. So 1. Is it available? Length 1. Yeah. In this case here, it's not OP. So num node will be pushed, and then this will be num node. And then 1 actually is the num node value, and then evaluate of num node should be val. So yeah, we don't need this. And let's do 3, 6, 3, and then this. So 6 will be pushed into the stack. So the stack will have 6, and then 3 will be pushed into stack, and then divide. So here we pop those two, 6 and 3, and then we push 6 and 3 into the stack. So st top will be div, right? And then yeah, some other complex something like this, and then 7, and then let's do this. Here stack will have 6 initially, and then 2, and then here is OP. So both are popped 6, 2. So 2 will be second, this will be first. So this will have mul node with 6 and 2. And then the next round, 12 is added by here. So 12. And then the next round, division will pop this 2. So this will be second by here. And then this will be first. So div, this will be pushed into the stack. So by here, this div will be returned. So by calling div, we'll first try to run this, and then left was previously multiplication. So here, it tried to evaluate this num. What was that? 6. So 6 will be returned, and then 2 will be returned. The multiplication is 12. So back to the div, this one is 12, and the right one will be 12 by this. So 12 will be returned, so 1 will be finally returned, right? And then here, there is follow-up. Could you design the expression tree such that it is more modular? For example, is your design able to support additional operators without making change to your existing evaluating? Yeah. So evaluates are always same, and when we need to introduce new operation, what we should do is that we should add the child of the OP node, and then we also need to fix here. So probably having some factory pattern will be better for this, but well, so I think this is it. Compile error, line 14, OP node. Ooh, hold on. I forgot this. Oops. Yeah. Run 63. Again. Oops. 81. Oops. Yeah. So, Also, we may want to check ch DAO must 1 and which is one of these. 17 switch token statement require expression or integer type. Oh, really? So I can't use this. Okay. So you want this. Minus, then times, and then division, and then finally else. Okay. 118 return st top st what? Okay. No matching function call a to I s to I okay, accepted, and then yeah, accepted. Yeah, I think that's it. So it took 32 minutes, 31 minutes, pretty long time, but it's okay. Percent. Yeah, acceptance rate is pretty high. This one is not that difficult one. One thing I'm thinking is that maybe we can have some kind of factory here, so that something like class op node factory. So what it does is that node op node get string token, right? Something like this. So here, what we can do is public static, and then you can return, and then we can return something like that. So here, instead of doing this, op node factory get token. So good way of doing this is that now this body is completely independent from what op node is, right? And then it is very easy to find whether which part need to be fixed if we introduce a new OP. So here is op node factory, so everybody knows that this has close relationship with op node. So Oops. User one declared. Oh, first. Okay. So get first. Yeah, like this will be better. So this is node first, node second, something like this. Yeah, of course this is const, this is const, and also this const, and then this is const, then const. Yeah, but it should make this also const something. Const. I don't know whether I can fix everything with this const. Static member function cannot have const qualifier. Why? The matching constructor add first, second. Because it's const probably. Let me delete all the const because this is just the algorithm test, not the design thing. So yeah, this will be fine. But in real life, we need to be really careful about const. Yeah. Okay. So this was pretty not difficult. So let me add this into my GitHub page. I like to design an expression tree with evaluate function. Yeah, I think it's pretty cool. Yeah, design is cool. Okay, I think this is the end. Bye.